Okay, so today we're going to look at another question on angle of elevation and depression. So we just learn how to solve more, complex problem that require more critical thinking. So we have a man 1.5 meter tall standing on the edge of a raised platform 1.8 meter high, views an object on a level ground at an angle of depression of 33 degrees. Find the distance of the object from the foot of the platform. So I always like to draw the level ground first. Any question on angle of elevation and depression, I like to just draw my horizontal floor first. So I think you may also want to do that. So we have the ground. Now this question says that the man is 1.5 meter tall. However, he's standing on a platform 1.8 meter high. So let's just draw a platform there. So let's say this is the platform. Okay, platform is just like a raised place where you climb to have a speech or whatever. So the distance from the horizontal ground to the platform is 1.8 meter. That's from the question. So this man is standing at the edge of this platform. All right, so what's this man's height? They said the man is, from the question you can see the man is 1.5 meter tall. So we're going to represent that 1.5 meter. That's how tall this man is. Okay, now the question says from this point he views an object on a level ground at an angle of depression. The first thing you might want to draw is, let's identify this man's line of sight. You know that the line of sight will be in this direction. All right, that means at this point he's neither looking up or down. So if he's in that direction, you can now attest to the fact that the angle of depression will be the angle that is formed below this man's line of sight, to the horizontal ground or the level ground. Okay, let's just say that this point O is the object he's trying to see. So he needs to look below his line of sight. So this angle formed here will be the angle of depression. So that is what you need to be very careful to note all these things. So they say that the angle of depression is 33 degrees. All right, and then we are asked to find the distance of the object from the foot of the platform. So we are looking for this distance from the object O, to this point. So you see, that's what I'm looking for. That's the foot of the platform. All right, so since that's what I'm looking for, let's call it X. So we're looking for this distance, we call it X. First of all, you need to know that this platform will always be at right angle to the horizontal floor. So that's 90 degrees. So you see that we have a right angle triangle here. Now, if you recall that from the previous video, we said that the angle of elevation is equal to the angle of depression from two common points. Why I'm bringing back this thing is because we can't use this angle 33 degrees now, because you see that it's not inside the triangle. So we need to get an angle that's inside the triangle. So we can say that the angle of elevation is equal to the angle of depression. That's alternate angles. So this angle here will also be 33 degrees. Well, if you also want to use this angle, let's say we wanted to use this angle now, this one. If you wanted to use it, we can still use it. What do you think will be the value of this angle? Because we can still get this angle that is inside the triangle. Now you see that the value of this angle, since the whole of this, you see that the whole of this is going to be 90 degrees, right? So if the whole of that is 90 degrees, so this angle, this one inside the triangle, is going to be 90 minus 33 degrees, and that will give us 57 degrees. So anyone we work with, you are expected to get the same answer. So it's very important for you to take note of that. Now we see we have a right angle triangle. Now you see that this side is the opposite side, since it's facing the angle 33 degrees. So we're going to call that side the opposite, right? So this is the opposite side. S is the adjacent. So we have opposite and we have adjacent. I think I'll just scroll down a little more. So, and we have adjacent. So you recall which of the trig ratio has the opposite and the adjacent, if you can remember your SOHCAHTOA. So you see that it is tan. We are going to use tan theta. So we have that tan theta now is 33 degrees. So tan 33 degrees will be opposite. Now, what's the opposite? You discover that this opposite, the platform is 1.8, the man is 1.5 meter. So we have to add the both of them. That will give us our opposite, right? So our opposite is going to be 1.8 meter, plus 1.5 meter, because the whole of that is the opposite, and we're going to divide by the adjacent side, which is x. So tan 33 degrees is equal to 1.8 plus 1.5 is going to give us that should be 3.3 now. Yeah, 3.3. So we have 3.3 meters divided by x. So we just cross multiply. We have x times tan 33 degrees is equal to 3.3 meters. So we just divide both sides by tan 33 to get x finally. So I'll divide both sides by tan 33. So tan 33 is going to cancel tan 33 there. So we're going to have that our x is equal to 3.3 divided by tan 33. So you can use your 4-figure table to get the value of tan 33, or if not, you can just use your calculator. So let's put the values in the calculator. So 3.3 divided by tan 33, we have 5.08 meters. So that's the distance of the object from the foot of the platform. Now we use this angle 33 degrees, right? We use this angle 33 degrees. Now what if we wanted to use the angle formed with the vertical, that's the 57 degrees? Well, we can also do that, and we are expected to get the same answer if we keep everything correct. So if we do that now, the only thing that's going to change is that our opposite side is going to change. For you see that x now will be the opposite, right, since it's the one facing the angle, and the other side will now be the adjacent. That's 3.3. remember, 1.8 plus 1.5. so we're still going to use tan, since it's opposite of our adjacent. We now have that tan 57 now, because I'm using the angle 57, will be equal to opposite, which is x now, over adjacent, which is 3.3 meter. So if we cross multiply, I have that x is equal to 3.3 meter times tan 57. You can also press this with your calculator to confirm the answer. So let me do that. 3.3 times tan 57. Of course, we have 5.08. And just so you know, I approximated this answer to 2 dp, two of them. So regardless of which method you decide to take, the distance is always 5.08 meter. So let's look at another question. This question says that a man 1.5 meter tall. So it's coincidence that the man is still 1.5 meter tall. So let's just continue. A man is 1.5 meter tall. Or rather, let me read this better. A man 1.5 meter tall is 16 meter away from a tree 8.7 meter high. What is the angle of elevation on the top of the tree from his eyes? So again, like I said, I always like to put my horizontal ground first. So that's the ground, and they say that the man is 1.5 meter tall. So we just let this line represent the man, 1.5 meter tall. And then he's standing 16 meter away from the tree. So let's represent the tree as well. So this would be the tree, of course. Okay, let's specify the measurements. So this man is 1.5 meter tall. The distance from the man to the tree is 16 meters. So that's the distance from the man to the tree from the question. And the tree is 8.7 meter high. Of course, that's the distance. So we are asked to find the angle of elevation of the top of the tree from his eye. So you see that you recall that we're going to put the normal line of sight. This is how this man will be looking. This time he's not looking up nor down. That's the normal line of sight. But the angle of elevation is going to be the angle formed above the line of sight. So from his eye, he needs to look up in this direction to be able to see the top of the tree. So the angle that is formed between the elevated line of sight and the normal line of sight is the angle of elevation. Let's just call it theta. We'll look for it. So you see that this area here is kind of a rectangle. So opposite sides are going to be equal. So we know that this side is going to be 16 meter, and of course this is a right angle. So I have a right angle triangle. So this 16 meter now, of course you can see, is the adjacent side, right? So the key step in this is to identify which is the adjacent, opposite, and hypotenuse. So you see that this is the total distance, or rather the total height from the ground to the top of the tree. Now we just want this height, all right, this is the height we are looking for, from the man's line of sight, to the top of the tree. That would be the height required. So if the man is 1.5 meter, as you can see, the 1.5 meter, I'm going to subtract it from 8.7. So this height here, this height we are looking for would be 8.7, which is the total height of the tree. We subtract what? 1.5 meter. So that will be the height. If we do that, you see that we have 7 minus 5 is 2, and then 8 minus 1 is 7. So that will be 7.2 meter. The distance here is 7.2 meter, and that's what we're working with. That's the distance from the man's line of sight, to the top of the tree. Now that we have everything set, we just need to now calculate, and of course you know that will be the opposite side because it's facing the angle. So this 7.2 is the opposite side. So let's go ahead and solve. So we have opposite and we have adjacent. That will be tan as well. So we're going to say that tan theta is equal to the opposite, which is 7.2 meter, divided by the adjacent, which is 16 meter. So you see that the meter will cancel. We'll have our tan theta equal to 7.2 divided by 16 would give us 0.45. Now we have tan theta equal to 0.45, but we're looking for theta, which is the angle of elevation. So anytime we have this, theta would be the tan inverse or the arctan of 0.45. So if you have your 4-figure table, you can also look at for what the tan inverse of 0.45 would be. If you have your calculator, just do shift plus tan and then 0.45. So let's do that. Tan inverse 0.45. And we have approximately, I'm going to approximate to 1 dp now. We have 24.2 degrees. And that will be the angle of elevation. So he had to elevate his line of sight 24.2 degrees to be able to see the top of the tree. So I believe that the concept of angle of elevation, as it has to do with when the observer, in the first case we solved, there was no height given for the observer, so we just had our angle of elevation from the ground, or from the top of the tree or something like that. But in this question now, you see that the height of the observer would be revealed. So we now have to draw our line of sight and then get the angle of elevation or angle of depression, as the case may be.